Saturday, June 18, another day, another dollop of misery. Day 4 or 5 or 6, I don't even know. Daily LeetCode. So I got a couple problems queued up today. Haven't done the ones up here in the top in maybe a year. But yeah, gonna try and go off the dome. But I'm gonna keep doing the usual ones until I have none to do, I think. And then I'm gonna try these. Or if I get to 10 minutes and I haven't done any of the ones on top, then I'll do those. Yeah. I think the audio is kind of trash, but maybe I'll fix that in the future, hopefully. But I don't know if I'm gonna try and teach them. There's other videos on the channel. I plan to make a specific video for each problem just to explain it, because I think that really helps with retaining the information. But I haven't gotten to it yet. But these I've already made videos for, the ones up top here, so those are on the channel. But am I gonna, yeah. Gonna try and stay focused. So I'm just gonna jump into it. Move zeros. I haven't done this one in a long time. So we have a function move zeros, which is an array of numbers, and we're not returning anything. So given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So you have nums 0, 1, 0, 3, 12, and I'm going to move all the zeros to the end. Interesting. Could you minimize the total number of operations done? Interesting. Array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. So I'm thinking maybe two-pointer approach here. You could have one pointer pointing at the start of the array, of the start of the array, and the other pointer would be the for loop, which is constantly moving towards the end. And if the right side of I guess we could call it the sliding window approach maybe. If the right side of the array or the right side of the window equals 0, then maybe we want to, so our start would be at 0. Yeah, if we meet a non-zero number, maybe we'd swap it with our last non-zero index. So 0 would be here. Then we'd have 0, 0, and then we'd have 3, which is a non-zero number. We'd swap 3 to 0 here and 0 to here. And then we'd increment our index once to here. And then 3 would be there and 0 would be here. Then index would go to 12, and then we could swap 12 with 0, and then we'd have 2 zeros and 1, 3, 12. So let's try sliding window approach. I equals, let's just start window start equals 0, something like that, and I'll set up some vim key bindings. And the second half of the window is actually going to be done by this for loop here. And then we're just going to say, like we said earlier, if nums sub no, we actually don't care where nums sub window start is. If num sub I, and actually because the confusing part about the sliding window pattern, should you start it at index 0 or index 1? So if we start at index 1 for this problem, 2 zeros, doesn't matter. It actually doesn't matter if we started at 0 for this one. So if num sub I does not equal 0, then what do we want to do? So we're at the first iteration here is 0, 0. Index I equals, last window start is going to be index 0, and I is also going to be 0. Both of these equal 0, so we're going to go to the next iteration. Now once index of I does not equal 0, what do we want to do there? We want to swap 1 with the window start, right? So we'll say nums sub window start equal nums sub I. Nums sub I equals 0. We don't need a temp variable to help with the swap because we're just going to put 0 there. So num sub I gets put to where window start is, and num sub I gets set to 0, and then we want to increment window start plus equals 1. And I think this should work, but I'm going to try it one more time, just running the code in my head. So we have 0, 1, 0, 3, window start equals 0, I equals 0, num sub I, which is 0, and we only want to do something when it doesn't equal 0, so we're going to skip this iteration. Then we're going to go to 1. 1 does not equal 0, so we're going to copy 1 into window start, which is index 0. Num sub I is going to get the value of 0, and then window start plus equal 1, so window start is going to be 1. Now 1. Now we're going to go to the next right end of the window. We're going to be equal to 0. Well, we don't do anything with it equals 0, so we keep going. Now we're at 3. Well, 3 doesn't equal 0, so we're going to copy 3 into here, which is now 0, even though it says 1. And then num sub 1, which is 3, gets the value of 0. And then we're going to go forward again to 12. Well, 12 does not equal 0, so num sub window start, which is now at index 2, is going to get the value of 12. And then we're going to copy num sub I, which is index 4, equals 0. And we don't have to worry about this 0 here because it was swapped in on the last iteration. So I think this should work. So we're going to click run. So that looks good. And it looks like this would be done in, oh, last time I did this was a while ago. 520, oh. When our input, interesting. When our input is just a singular array, not 1, then what happens? So nums window start equals, oh, they equal the same thing. You know, it might just be easier to start it at the second one. I think you should still get the same output. Okay, you don't get the same output. Now I'm guessing. So I'm going to go back to the start and rethink the part with the singular case. Well, if the array has one element in it, then we probably don't want to do anything. So if num.length equals 1, then we'll just return. What about when the array has 2 elements in it? If it has 2 elements, let's just make believe 1, 0. Or let's make it like this, 0, 1. Then window start would be equal to 0. Num sub I would also be equal to 0. So we'd skip this in this iteration. Go to the next one. Well, num sub I now does not equal 0. Num sub window start, which is index 0, it gets set to the value of 1. Num sub I equals 0. So we would swap them in window start plus 1. So maybe this should fix it. Or maybe I should then less than or equal to 1. Okay, so when our input is 1, 0. Oh, wait. Oh, we did 0, 1. We didn't do 1, 0. So if our input is 1, 0, then we should return 1, 0. So I equals 0. So, okay, so our input is 1, 0. Window start is going to be equal to 0. And I is going to be equal to 0. Does num sub I, if num sub I does not equal 0, well, it doesn't equal 0. So we're going to do num sub window start, which is index 0 equals num sub I. So we're going to overwrite one with 1, and then we're going to do num sub I. And so actually I'm thinking maybe if we, I think it should, I have a hunch that this should start at the second indice. Then it's wrong here. Something is incorrect about this process. Something's incorrect. So if we have 2, 1, output is 1, 0. You know, it might be the idea that I'm actually just replacing it without, or just always assuming we're going to put 0 back into the other spot. So maybe we can just return this to 0 and just do swap regularly. So since we're replacing Windows start, we're going to put Windows start into temp. Num sub Windows start equals num sub I, and then num sub temp. Num sub I should get the value of num sub temp. I think this should work. Okay. Yeah, I kept assuming I was always going to be putting 0 in, but that's not the only time we swap. So this is going to be linear time, where the number of operations is going to scale with the number of elements in the array, and constant space. So I'm going to classify this one in my head as sliding window pattern. Okay, yeah, I thought there wouldn't be that many problems to do today. So we did move zeros. So we're going to do some new ones. We'll start with palindrome linked lists. 10 minutes. I don't think we can do all these, but we'll try. You have a list node, right? It has a value in the next pointer, right? It can be list node or null. And the constructor lets us set a value or a next value, right? Both are optional. And this constructor makes sure that if either are undefined, then we'll set them equal to 0 or null respectively. So function is palindrome. Given a head, they want us to go through the linked list. Okay. Okay, they're giving us a head node and they want us to return a Boolean. Okay, so given the head of a singular, I'm going too fast. We have a function is palindrome. And we're getting past a singular list node, which is going to be the start of the linked list. And we're going to return a Boolean. Given the head of a linked list, return true if it is a palindrome. Well, a palindrome is a structure that is the same forwards as it is backwards. So 1, 2, 2, 1 is the same forwards as it is backwards. So I think we can actually do this with a stack, but that would be linear space. Maybe there's a better way. There's probably a better way to do it. I think, actually, I don't know if you can do it without doing linear space. The stack would be linear time and linear space, but I don't think you can do it without a stack. If you go to the linked list, you could reverse it. You could reverse it, but then you wouldn't have, oh, if you kept a pointer to the head and then you reversed it. No, that doesn't make any sense, actually. Actually, maybe there's a way. Oh my God, I think you could do it. Okay, I think you could do it. I think this only may work in JavaScript. If we take the list node, we could create a new property on it called tail. So we could do const temp equals head. I'm going to set up the bin bindings here. This might only be possible in JavaScript, but we could turn it into a doubly linked list. And so if we keep const temp equals head, we could do while temp does not equal head. And then what we'll do, we'd also need temp slow, which would be equal to null. And what we would do to create a doubly linked list from a singly linked list, we'd have one pointer at the front and one node behind. But I'm a little fuzzy on how that starts in the beginning. One pointer behind. So while temp does not, while temp does not equal null, we want to set temp dot, TypeScript, maybe they would let me do this actually. If I do temp dot pre temp as, if I do as any, maybe it won't mind. I might get a type error though. I'll do temp dot previous equals temp slow. temp.prev equals temp. Because the next ones are already set up. We just want to set the behind ones set up. So temp.prev equals temp.slow. Then we would do the increment step for both of them. So temp slow equals temp, and temp equals temp.next. And this should give us the linked list in reverse. Okay, so we're gonna get temp slow equals null, which is gonna be out here. Temp is gonna equal to head. Temp, which is 1, isn't null, so we're gonna say temp.prev equals null. Okay, then we're gonna go temp slow equals temp, so temp gets set to 1. Temp equals temp.next, which gets to 2. 2 isn't null, so temp slow. 2 isn't null, so temp.prev gets set to index 1, which is good. And then temp slow gets set to temp. Temp equals temp.next. 2 isn't null again, so temp.previous gets sent to temp.slow, which is temp, which is 2. Temp slow equals temp, which is now 2. Temp equals temp.next, which is 1. Now temp isn't null, so temp previous gets sent temp set equal to temp slow, which is 2. Temp slow equals temp, which is 1, and temp equals temp.next, which is null. Now temp does equal null. This is actually perfect. And then temp slow would actually equal the end of the list here. Then we can iterate between temp and temp slow together. Since temp is 1 behind temp slow, we actually can't keep redefining these if both these are cons. So temp slow is actually going to be 1 node behind it. And so it should be at the end. And then we should just be able to do temp equals head again. Then we'll do while temp slow does not equal temp. Whilst temp slow does not equal null, and temp does not equal null. If temp slow dot val does not equal temp dot val, then they're not a palindrome, right? We want to return false. If we make it out here, we can return true. And then they're going to increment different ways. So they're going to be incrementing towards the center. And they actually have to pass each other, unfortunately. So they'd be 1, 1 together, 2, 2 together, and then 2, 1, 1 together, and then 2, 2 together, and then 2, 2 together again, and 1, 1 together, and then null, null together. So we actually have to do, it would be linear. So okay, we do temp equal temp dot next, and temp slow equals temp slow dot previous. This should work. It really should work, but we'll see. Oh my God. Okay, that is pretty satisfying. That's pretty satisfying. That was like a brain blast Jimmy Neutron moment. No way. Actually, no way. I might be pioneering new ground in the linked list solutions. There's no way. Copy into array, then use 2-pointer technique. Recursive advance. This is recursion. Is this a linear term? Is modifying the input in place. All right. To reverse the second half. Okay. It doesn't always work because you probably don't want to break the input like they're mentioning here. Then comparing it with the first afterwards, we should re-reverse the second half. I think I forgot how to reverse the linked list. Actually, no, never mind. I didn't forget. But you'd have to re-reverse it twice. Interesting. That was satisfying. That was very satisfying. There's only 50 seconds left. Allison took a lot of the time. I might go a little past the time as usual though. So we have a list node, val number next list node or null constructor val number. So we have val next list node. Constructor just simplifies creating the value with the next. And then we have to delete a node in the linked list. We're given root, list node, or null. Write a function to delete a node in a singly linked list. You will not be given access to the head of the list. Instead, you'll be given access to the node to be deleted directly. Oh. This says root here. So the node to be deleted directly. It is guaranteed that the node to be deleted is not a tail node in the list. Given node, okay. So is this just root? If we're given this node, don't we want to just set this node equal to root.next? This seems strange. Why aren't we given access to the end? Why isn't the node we're given to be deleted at the end of the list? So it's not a tail node. If we're given 9, we can't say this equals null. I mean root equals null. We could though. This seems strange. It seems like the solution is one line, but it doesn't make sense to me. If we're given the access of the node to be deleted, we would say root equals root.next. My input is 4519. My output was 4519. Oh, I guess we can't change. In C++, you could probably do this maybe. This one line. Root equals root dot next. It's guaranteed that the node to be deleted is not a tail node in the list. Write a function to delete a singly linked list. Node in a singly linked list. You will not be given access to the head of the list. Instead, you'll be given access to the node to be deleted directly. It's very strange. Maybe there's a secret cheat code here. If we're not given access to the head, if we're given 1, then how do we set it equal where we currently are? Oh! I just figured it out. You can't change where we are in memory. Maybe you could do this in C++ with ampersand or something like that. But deletion is almost, if you delete something, if I was told to delete something, I think you could just by copying it. So you could say root equals root.val equals root.next.val. And that's why the element that we're given at the end isn't a tail node. Because if we're given a tail node, then if we say root.value because root.next.val, it's like undefined behavior. So if we're given to delete this node, we could copy this node's value into this node and set it equal to 9. And then we'll wrap, right, we also can't wrap around it. So I see. So we would, okay. So we copy 9 into here, and then this next pointer would have to wrap around this node we just copied. So next.next will be ripped from here and pushed all the way out here, which could be null. I'm say root.next equals root.next.next. I'm feeling pretty confident about this one. Okay, maybe it's, oh, okay. Okay, that actually makes sense. Yeah, I haven't done this one in a long time. Interesting. That is interesting. This is constant space and constant time. Oh no, I can see, oh god, I saw what I wrote a long time ago, but I don't know what it means. It looks like spaghetti code, what I wrote though. Given two strings s and t, return, so we're given a function is anagram as a string s and a t and string t, and it returns a boolean. Given strings s and t, return true if t is an anagram of s, and false otherwise. What is an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters once. So, anagram, nagaram. Okay. Are there any constraints on this problem? S and T consist of lowercase English letters. You know, actually, I think we could tell if something was an anagram. You could do this in a little constant space. I think you could do this in constant space if you used a map. If you used a map, right, and it'd be constant space because if S and T only consist of lowercase English letters, then the maximum number of indices you would ever take up in a map would be 26, even for two arbitrarily large strings. If that's the case, then we don't even need two separate maps. You could fuse them into one and then count the occurrences of the letters, and we'd have to make sure that all of them are even if a string could be rearranged. So for example, if we had rat and tar, we'd put these into a map, we'd get T2, A2, R2, and we could count the occurrences mod 2, and we'd have to make sure that they all equal 0, that our count equals 0. That way we would know that we have two copies of every letter. So let's try that. Const map equals new map string to number. We do const. I don't think you can iterate over two strings at the same time. Or at least I don't know how to do that. So we're going to do const car of s. And I'll set up this quick binding. We'll do const value. We could actually make this a function. Const value, if the map has the value for a car, then it's going to get that value for car. Otherwise, it's going to return 0, and we're going to do map dot set car value plus 1. Then we can duplicate this, and we'll do car const car of t. Run the same thing, and then here we'll just do create a variable called count, and we'll do for const do const pair of map.entries. We actually don't need both though. We just want, maybe you can destructure the tuple out. I think the first one provided is the indice, and maybe this one would be the occurrences. I don't know if that's valid JavaScript. I don't know if that's valid JavaScript. And we'll say CT plus equal occurrences mod 2, and we'll return if CT equals 0 as the anagram. So if we have rat No, wait. This might not actually be correct. You could design an input for this to fail. For example, if I put car, or I put AA, BB, CC, and then I added a new one, DD, EE, FF, count would be equal to 0. Even though they all had different letters. I think another thing we could check, I could also do this, is if we do and map.size equals t.length and map.size equals s.length. And we can actually make this even, I think it could be even simpler if we do map.size equals s.length, and then up here we'll just say if s.length does not equal t.length, right, then we're just going to return false. If they're already not anagrams if they don't have the same number of characters, right? Secondarily, if we go down here, if we get here, we know for certain that they have the same number of characters. And since they have the same number of characters, we can check if the count equals 0, which means that we have an even number of all occurrences, and the map size is the same as s.length, is the same as saying, does the map size equal the length of both strings? Because we know they equal the same length up here. So let's try and run this. This expression is not callable. Return CT equals 0 and map.size equals s.length. I wonder why this is not callable. Looks like I'm returning a Boolean expression. I wonder why that's happening. I'm supposed to return a Boolean, turn CT equals 0, and map.size. Is map.size not what it is? Equals s.length. That's very strange. It's a compile error. Oh, maybe I'm actually confused. This expression is not callable. I'm not calling anything though. Let me try and remove the other case. I know this is not going to be valid, technically. It might be valid for the first case, but there is an input where this doesn't work. Maybe the function is not map.size. Or actually, maybe we'll see. Okay, yeah, this is what I meant. AA and BB would pass the map, but it wouldn't be the same. And I think the solution to that problem is map.size, which would be 2, have to be equal. Oh, wait. Map.size would be equal to 2, would have to equal to both A and T. Dang. Maybe I think I know of another way to solve this, but I really wanted this one to work. I think you can do this just by sorting the strings. Keep that first line I have on line 2, sorting the strings, and then just doing a comparison on each character. God make the runtime n log n. And I think there may be a solution. N log n. Or is that yeah, I think that's, yeah. I really wanted this solution to work. Sometimes you gotta play the cards you have, not the cards you want. But I really want this solution to work. CT equals 0. CT equals 0. Yeah, I mean the simpler solution is n log n, but this one would be constant time n. No, it wouldn't be n log n actually, because we have two strings. It would be s log s and s log t. Return CT equals 0. Yeah, something's not added. The problem being that we can have AA and BB, and even if the map.size is equal to 2, the map.size would be equal to 2. Map.size would be equal to 2. The map.size would be equal to 2, but the number of occurrences would be 2 for both. Let me just compare this. If I had AA, if I had a string AA, BB, and BB, AA, this could be rearranged on palindrome. The map for this would look like A equals 4 and B equals 4. But if I have AABB and CCDD, the map for this looks like A equals 2, B equals 2, C equals 2, and D equals 2. Isn't that the problem we ran into though with AA and BB? AA and BB, it was A equals 2 and B equals 2. The map.size would be 2, and the length of both strings would also be 2. A equals 2 and B equals 2. Dang, I really wanted this solution to work. I need to let it go though. I really wanted this one to work. A equals 2 and B equals 2. A equals 2 and B equals 2. I can't see through the fog. I really want this one to work. A equals 2 and B equals 2. Maybe it's time to let it go. Oh man, it's hard to let go though. This one makes more sense. I think it's more reusable for other problems. There's a similar problem for palindromes, which reuses another solution like this. A equals 2 and B equals 2. What's the differentiating factor between these? Let me make one more case. The case where this passes. A equals 4. Oh my god, I think I figured it out. It's not the case that map.size has to equal each string. It's the case that map.size, or the sum of the occurrences, no, never mind. AABB, I can't think of a line of code I could add where AABB doesn't pass and AAA passes. Differentiating factor here is that A equals 4 in this case. AABB BB AABB A equals 2 and B equals 2. A equals 2 and B equals 2. I sound like a broken record. Bro, I don't understand. There's got to be a way. I'm spending too much time on this problem. Nah, this is the way. This is the way. I think this is the way. You could solve it just by sorting the strings and comparing them, though. So yeah, I'm being a little nutty. It's frustrating, though. A, B, 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 A. A, B, C, D equals 2. All these equal 2. A equals 2, and B equals 2. A equals 4. A. Some of the keys and the sum of the occurrences. The other case would be if we had A, B, B, A. A equals 2 and B equals 2. The only thing that makes sense is the occurrences. I'll try one last time, and then I'll move on. I want to see the case that I got stuck on. For this specific solution, it was A, and B, B. I return true. For this case, A would be equal to 2, B would be equal to 2. Oh my god, I think I just had a brain blast. No, never mind, it's false. Never mind. Yeah, I think I just have to accept my fate. Is there another one that we could do besides this version? I don't like the sorting one. The sorting one is n log n. I feel like there's a linear solution to this. Or not linear time, but s plus t time. This would be s plus t. But the other one would be s log s plus t log s plus t log t. Admittedly is worse. Sorted s is equal to s dot sort a minus b. AB a minus b. And then we could do const sorted t. Wait a second. No, yeah. Equal. And then I think you could just check them. So you could do let left equals index 0 and let right equal s dot length minus 1, while left is less than right. We'll say if left, if s sub left does not equal t sub right, then we would return false. If we make it out here, we return true, and then we do left plus equal 1, right minus equal 1. Let's double check this with A, and B, B. They're the same length, so we'd keep going. We'd sort A and we'd sort B. They would still be in this exact order. Left would be 0, right would equal index 1. 0 is less than 1. 0 is less than 1. S sub left is A, and T sub right is B. They're not equal, so we return false. Could also do 2 lowercase, but I don't think they care about that. I also don't know if you can sort strings that way in JavaScript. So maybe you can't do this. Sort does not exist on string. So what we could do is we could spread it into an array. The left side, line 3, you type any number. I see. How do you get, oh, we could do car at. Dot map car. Or how do you turn a number into an ASCII value in JavaScript? I think it's car at. String.car at. Car at as a particular index. I don't know if what I'm doing here is valid. I might be doing anything at this point. Actually, this is starting to remind me of, I didn't exactly see what I wrote when I first started this, but it's starting to look as convoluted. Long time pending. Must be a lot of people on Saturdays at 1:52 p.m. Oops, let me redeclare. Argument of type string is not assignable to type number. Huh? Argument of type string. Argument of type string. Not assignable to type number. If I have a string, S equals ABS, then you spread it into an array, and then I do map IDX car S dot car at IDX. Maybe you can't do that. Or maybe it's in reverse. Oh, it's car. You get the value, then you get the index. Interesting. Car at IDX. No, it's not car at. That gives you the character. What I'm looking for the ASCII value. I don't know how you get the ASCII value. I don't want to Google it though. Maybe you can do something like this. You could do number car. Okay, you can't do that. Number is not defined. I don't know how to turn a character into an ASCII value. But I feel like you should also be able to sort them by strings. If you do s.map, you should be able to just do s.sort a minus b. Okay, let me try hello. It comes out the same. So the sorting clearly doesn't work.